describe physics as a science, you guys are probably under the impression that it's as far away from art as bananas are from berries or astrophysics is from rock music. Well, today we're going to be looking at how those things are more similar than you might think, and how art is in one-dimensional movement and kinematics. Hello, welcome back to Fast Physics, where I try to introduce topics in physics to you guys. So I hope that I drew you in today by mentioning art, because I think that most people are way less intimidated by the idea of art than they are by the idea of physics or any other kind of science. Why exactly is that? Well, to answer that, let me reintroduce myself. My name is Maggie, I'm 15, and if you've seen any of my other videos, you probably already know that I'm definitely not an expert in physics. What you probably don't know is that I've been learning art for much longer than I've been learning physics, so I hope that I can shed a little bit of light on that question that we asked earlier. Why is art less intimidating than physics is? Well, I think it has to do with the way that people see art and physics. People usually see art as something that's super subjective, something that has to do with the way that you see the world, and how you express that through a certain medium, whether that's photography or sculpture or painting. That's in comparison to the pretty common perception of physics as something that's super objective. If it's wrong, and nobody, including me, likes to be wrong. And while I'm not saying that you should make a whole bunch of mistakes in physics, I don't think that that's a really fair way to compare the two subjects. The way that we use math and physics is actually really similar to the way that we use the basics of art in art. And that's really where most mistakes are made, both in physics and in art. Once you get past the basics of both subjects, you can apply them to do basically what the essence of both subjects is: expressing something about the world through a certain medium. So just like bananas are actually considered berries, and Brian May is both an astrophysicist and a member of a rock band, physics and art are two subjects that are actually really similar and have the same ultimate purpose: showing other people a part of the world. So let me introduce one-dimensional movement and kinematics in terms of the elements of art. So once upon a time, a long time ago in 7th or 8th grade, which was about 3 or 4 years ago, I had this really awesome art teacher who not only taught my class the elements of art, but also how to apply them to compositions. Now, I have no clue if she ever expected me to apply them to physics, but I hope that I do her justice. The 7 generally recognized elements of art are line, shape, form, color, value, texture, and time. The reason that a point isn't on there is because it's considered to be too basic, and the element that all the other elements are based on, because it's defined as a singularity in space. We can compare that to the scientific concept of position. A point is a singularity in space, just like a position is your location in space. Now, if I ask you to describe your location right now, could you really do it without referencing anything else? If you say that you're sitting in your chair in your house, you're referencing both your chair and your house. If you say that you live in the United States or in Canada or wherever you happen to live, then you're referencing the country that you live in as your frame of reference. Even if you try to be sneaky and say that you're at however many degrees of latitude and however many degrees of longitude, you're still inadvertently referencing the prime meridian and the equator, because those are what latitude and longitude are based off of. In physics, we call those things reference frames, things to base your position off of, and we can write your position numerically as x, or the distance that you are from your chosen frame of reference. That's how we use coordinate systems too. Like we saw earlier with latitude and longitude, which base your position off of your distance from the equator and the prime meridian, coordinate systems show your position by relating to axes as references. So now that we've established what point, position, frame of reference, and coordinate systems are, let me introduce one of the actual elements of art, a line. Line is actually probably my favorite element, especially because of its definition. In lyrical terms, it's defined as the path of a point as it moves through space. So let's think about that path. As you travel along a path, your position is changing and you're moving in a very specific direction. In physics, we call it displacement, and we can refer to it as delta x. The delta means change in, and the x, as we learned earlier, represents your position in terms of your distance away from your chosen frame of reference. So altogether, we have that displacement is your change in position. Now, how exactly do we find that? Well, numerically, we can represent that as your final position minus your initial position, which gives us your change in position. Keep in mind, though, that both of these have to be referencing the same frame of reference, or it won't be accurate. But you're probably thinking, why is distance inside the definition of displacement? Aren't they basically the same thing? Well, they're actually not. Distance and displacement are actually two different kinds of quantities. We call them scalar and vector quantities. Scalar quantities, like distance, only have magnitude without direction. The distance that you travel is kind of like the steps that your phone or watch records. It only tells you how many steps or miles you've traveled in a day, whereas my phone might tell me that I've traveled 3.7 miles in terms of distance. I haven't actually been displaced at all, because even though I moved a distance, my final position and my initial position are exactly the same. I'm back in my house exactly where I started before I went outside for the day. Direction is also really important in distinguishing between scalar and vector quantities. If I were running a marathon, my distance would tell me that I'd run 26.2 something miles, but it wouldn't tell me what direction I'd run those 26.2 miles. On the other hand, my displacement would tell me both my distance and the direction that I run that distance in. It would still tell me that I'd run 26.2 miles, but in whatever direction the marathon had been in. That's also why speed and velocity are different things, because speed is based on distance, which is a scalar quantity. Speed is also scalar. On the other hand, velocity is a vector quantity because it's based on displacement, which we saw earlier was also a vector. When you find something's velocity, it has a definite speed, which is its magnitude, but it also has a very definite direction. As we go on through physics, we'll come to see that a lot of the quantities that we encounter can be grouped as scalar and vector, so something to look forward to. Thank you for watching this video, and I hope that you learned something about physics and art today. If you want a more in-depth look at either of them, be sure to check out the links in the description of this video. Remember to like and subscribe, and tune in for my next video about velocity and speed on Monday. Bye!